All right, my mathematicians, today we're going to get into section 4, which deals with direct variation. So previously we found rates of change of linear functions, and now we're going to write and graph direct variation equations in this first video, and then in the second one, we're going to talk about how to solve problems involving direct variation. So here's our new vocabulary with something called direct variation, which obviously we'll get into, constant of variation, and constant of proportionality. And I will tell you that we use direct variation all the way up even in calculus. So this is something that's you're gonna see it again and again as you go through your math courses. So in this video, like I said, we want to talk about direct variation equations. So a direct variation is described by an equation of the form y equals kx, where k is not 0. Otherwise, it would just be like y equals 0. So the equation y equals kx illustrates a constant rate of change, and k is called the constant of variation, and it's also called the constant of proportionality. So constant of variation and constant of proportionality, talking about the same thing. It's the number in front of x in the direct variation equation. So name the constant of variation for each equation, then find the slope of the line that passes through each pair of points. So the constant of variation for this one is 4. You can see the equation is y equals 4x, negative 4x. And so the constant of variation is negative 4, the number in front of x. The slope is the change in y over change in x. So again, if we label our points, this one would be x1, y1, and this one would be, this is x1, y1, and this is x2, y2. So we just plug the numbers in. 4 minus 0 over negative 1 minus 0. Then you simplify and you get 4 over negative 1, which is just negative 4. That's the slope. So here the constant of variation is a half because it's the number in front of x in the direct variation equation. And we do the slope formula. Notice that this point isn't labeled, but it's at the origin, so I know that its coordinates are 0, 0. So I do 3 minus 0, it's a change in y. And then 6 minus 0 is the change in x. And you get 3 over 6, which reduces to 1/2. So let me back up a second. So if you notice, the slope of the line is the same as the constant of variation or the constant of proportionality in these two equations. You probably noticed that really quick. All right, here's a couple for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So for 1a, the constant of variation is 1/4. It's the number in front of x. The slope is going to be 1 minus 0 over 4 minus 1, 4 minus 0, which is 1/4. You should get the same number for the constant of variation and the slope if you did it right. 1b, what do we get? Well, the constant of variation or the constant of proportionality is negative 2. The slope is going to be negative 2 minus 0 over 1 minus 0, which is negative 2 over 1, which simplifies to negative 2. Again, we got the same thing, so probably right. It's a good way to check your answer. All right, so the slope of the graph y equals kx is k. And since 0 equals k times 0, the graph of y equals kx always passes through the origin. Therefore, the x and y intercepts are always going to be 0 for the graph of a direct variation. All right, now where we got this 0 equals k times 0 from, it right here, is the fact that if we plug the coordinates of the origin in, okay, you're always going to get 0 equals 0. So if we want to graph y equals negative 6x, we can first write the slope as a ratio if it's not, so negative 6 is negative 6 over 1. Then you graph the origin, so 0, 0, and then you use the slope as kind of directions for how to get to your next point. So since the slope's negative 6 over 1, you rise negative 6, which really means go down 6, and run 1. So I would go down 6 and over 1, and this is my point. Okay? And you could do it again. You go down 6 over 1 You could get a second point. Now 12 would be down here. Okay. Now, if you don't have enough room, you could actually go backwards. In other words, you could go up 6, back 1, and then that would give you another point. Okay. So try to draw a good line there. All right. And the line just connects through the points. Now these arrows down here were just directional arrows I was drawing just to show you that I was going down 6 and forward 1. I'm going to erase those because those really aren't part of, aren't part of the graph. Okay, the graph is just the straight line that goes through the points that we graphed. Oops, back. Okay, all right, so here's a couple for you to try. Go ahead and pause the video and hit play when you're ready to check your answers. Okay, we're back. So y equals 6x. Plot the origin, and then the slope is 6 or 6 over 1. So in this case, I'd go up 6 over 1, which is right there, and then up 6 over 1 again. Or if you went backwards, you could go down 6, back 1, just the opposite direction. Okay? And if you do it right, all of your points should lie in a straight line. If you did something wrong, you'll see like a kink in your line or something like that. And remember, the first point for these, all of these, is just the origin. So for the next one, the slope is 2/3. So I put the point at the origin, and then you rise 2, run 3, up 2 over 3, up 2 more over 3, up 2 more over 3. Or you could start at the origin and go down 2, back 3, down 2, back 3. And you'll see the pattern. You'll see that all the points lie on the same line. Pretty cool. All right. C, the slope is -5, so that's -5 over 1. So we start at the origin, go down 5 over 1, down 5 over 1. And you'll notice for these, if the slope is positive, the line is rising from left to right, and if the slope is negative, like this one, the graph is falling from left to right. Now, what happens when you have a negative right in front of the fraction? Well, what you don't do is put a negative on the 3 and the 4. I've seen people go, oh, that's -3 over -4. No, because then you have negative divided by a negative, which is a positive. Okay, and then you've just changed the problem. Really, it's saying that -3/4, that the 3/4 itself is negative. So you could either think of this as -3 over 4 or 3 over -4. Really doesn't matter. If you did -3 over 4, you'd put a point at the origin, and you'd go down 3 over 4, and you'd have that point. If you did 3 over -4, you would rise 3 and go back 4. Okay, but notice if you did it -3/4 or 3 over -4, you would get the points would be on the same line. You would just get one forward or one in reverse. Either way, if you do it correctly, you're still going to get the points that are on the same line. Okay? All right. So the graphs of all direct variations share some common characteristics. The direct variation equation has the form y equals kx, so it's always y equals whatever the constant of proportionality is times x, and the graph of y equals kx always passes through the origin. If k is positive, the graph has a positive slope and rises from left to right. If k is negative, like here, the slope is negative and the graph falls from left to right. So if the relationship between the values of y and x can be described as a direct variation equation, we say the phrase y varies directly as x. So if you have a problem and it says blah, 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 y varies directly as x, you should be thinking in your head, oh, it has the equation y equals kx. Okay, because they'll do that. They'll say y varies directly as x, and you would need to know that the equation is y equals kx, and therefore that's how you can get started on some of these problems. Just like this one. So suppose y varies directly as x and y equals 72 when x is 8. Write a direct variation equation that relates x and y. So here, they didn't tell you the equation, they didn't tell you k, but they gave you x and y. So since I know it varies directly as x, I know that the equation has the direct variation formula. So I set up y equals kx. Then you could substitute what I know. I know that 72 is y and 8 is x, so I can replace those, divide to solve for k. Now this is the value of k in your direct variation equation. Now you have to write the actual equation. So the direct variation equation is y equals 9x, okay? Now, what that indicates, or let me say it like this, don't write 72 equals 9 times 8 and think that's your equation. The 72 and 8 was just one specific coordinate on the graph to help you figure out the value of k so that you could write the general equation. Okay, here's another one. Use a direct variation equation to find x when y is 63. This is part B actually. So now I have the equation, and they want to know what x is when y is 63. So now I know what k is. I can plug in 63, solve for x, and I get x equals 7. So therefore, x equals 7 when y equals 63. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready. All right, we're back. So suppose y varies directly as x. So that means that we're going to be using the equation y equals kx. And y equals 98 when x equals 14. So I can plug those in. 98 equals k times 14. Write a direct variation equation that relates x and y. So I could divide both sides by 14 to solve for y, for k. So the equation is y equals 7x. That's the equation. Then I want to find y when x is 4. So y equals 7 times negative 4. Be careful that you pay close attention to what they give you. Sometimes they give you x and ask for y. Sometimes they give you y and ask for x. So just be aware of what's going on there. So y equals negative 28 when x equals negative 4. Okay? So they actually asked for two things. It asked for the direct variation equation under the given circumstances, and then it asked for the value of y when x is negative 4. All right, guys, that's it for this video. Stay tuned for the next one. And in that video, we're going to talk about some direct variation problems. All right, so we'll see you there.